So you can either do the limit and then do L'Hopital's rule, because this is infinity over infinity, so you can use L'Hopital's rule. You guys with me so far? The bottom's a little bit gross, but not crazy gross. Or, does anybody remember, you can divide the top and bottom by the highest degree. Does anybody see what's the degrees of the top and the bottom?
One.
They are the same degree. That's what's important, right? They're the same degree. So then the end behavior, the limit should be the ratio of the coefficients, right? So if you divide by x, and down here I'm going to divide by x. So I get 1 over square root of 1 minus 1 over x squared, and when x gets really big, it's 1. Does that sound familiar at all? You can attack radicals inside of polynomials, because radicals are like one step away from polynomials. Poor little dudes. They have fractional powers, and just because of that, we throw them out of the group. Aw. But the actual idea behind them then is the same. It's kind of neat. Maybe. Yes?
I don't understand, like, where, when you do the square root of x squared and then divide, like, why doesn't it get rid of the other square root? Like,
Oh, so square root of x squared minus 1 over square root of x squared equals square, you just bring it inside. Yeah, you can't cancel the square roots. Yeah. I like it. And what about when x goes to negative infinity? What's going to happen there? What do you think? The bottom is going to stay, the bottom is always what sign? No matter what I plug in there.
Positive.
Positive. I love it. And the top is negative. So what do you think that's the limit's going to be? Same idea. You guys see the symmetry here? Same idea, except it's going to come out to be negative. Isn't that what we said earlier? I mean, what is this? Two different things, depending on if x is positive or if x is negative. How do you rewrite absolute value of x squared? What am I getting absolute value? I'm thinking ahead. How do you rewrite square root of x squared? Absolute value of x. There it is. And the absolute value of x is x or negative x, depending, right? So that's why the answer comes out to be 1 or negative 1. Okay, maybe. No? What happened there? Alright? Do you guys remember this? This fact. Because what's the square root of negative 3 squared? 3. It's the absolute value of negative 3. Thank you. So that's what the square root of x squared is. It's the absolute value of x. Right? It's being very careful. Do you know what x is? No. So just in case it's negative, let me slap some absolute values on that bad boy. It's one way to look at it. And there's a good sound effect. Alright. What do we got here so far? So we got domain. We've got end behavior. EB. Looks really weird. It looks like this. 1 and negative 1. Which means those are the
limits.
yeah, there you go. Horizontal asymptotes. So y equals 1, y equals negative 1. Any vertical asymptotes? It's a little weird at 1, for example, right? I mean, it's going to go to infinity then, isn't it? At 1 and negative 1. I like it. So it looks like this vertical asymptote's at, or something weird at least at 1 and negative 1. Maybe. Because remember, where do vertical asymptotes come from? The things that are left out of the domain. Now the whole chunk in the middle, in between negative 1 and 1 is just empty space. But right at negative 1 and 1, something strange is going on. Either open circles or asymptotes. Okay. And then you can start attacking this with calculus, right? How would you do this guy's first derivative, for example? Increasing, decreasing, extrema. Yeah, you could. You could take that up and make it a product rule.
Well, it's technically 1 over square root of x squared minus 1 times x.
No. You can't do the derivative of each piece separately. We know this. right? You can't do the product, can't do the derivative one and derivative other times. So the same thing doesn't work for division either. You have to use quotient rule or bring it up and make it product rule. Here I'd rather use quotient rule, to be honest. Because, whatever. I'll tell you why. This is where I sort of relented when I was a student. What are you going to want to do with the first derivative when you find it? What are you going to want to do with it? Set equal to 0. So if I keep things consolidated, it's going to make that step easier, right? So those of you who like my idea of always making a product rule, here's one place maybe you don't want to do that. You want to keep it consolidated. So if I write this better, how do I do this guy's derivative? Top first, I like it, good. Times the bottom. Minus.
Or half X.
1/2. Yeah. 1/2 times this to the negative 1/2 times 2x. I like it. Oh yeah, times x. Thank you. All over. Yeah, the bottom squared is one of those things. I love it. All right, kick ass. So then I get squared minus 1 to the 1/2. 1/2 of 2 is gone. I get x squared. All over this. Okay. Let me stop here for a second. That is gross.
A little bit.
So there's two ways to kind of approach this. Again, anything fractional, anything rational, how do I make it 0? Top's got to be 0. I like it. The top is a little bit gross to work with right now. Whenever you see this, whenever you see 1/2, negative 1/2, stuff like that, if I multiply the top and bottom by this, what's going to happen? What's going to happen here if I multiply it by this? What do you do with the powers? It's going to become 1. I love it. It's going to be x back to the 0 power, which is 1. That kicks x. And I'm going to make a whole one of them here. I'm going to have like terms. Thank God. So if I multiply top and bottom by this, it'll look a little better, right? Yeah. So I get a whole one of these. So that times that is a whole one of those. That times that is 1. The whole thing is to the 0 power now. So minus x squared. That kicks a lot of ass. And on the bottom you get x squared minus 1 to the 3/2. So I get negative 1 over that. Is that ever equal to 0? No. Where's the other place I get critical numbers from?
In this room. Or
Undefined. I like where it goes to infinity or something, right? So there's no critical numbers. X is f prime is never 0. But when is it undefined? We know where it's undefined. True, and we already know what that is. 1 and negative 1. I like it. So my critical numbers, negative 1 and 1. I like it. I know. It's about out of time. My point with this problem, the reason I wanted to do this problem, I knew I would never finish this problem, but how much have we realized we have to remember for tomorrow? I mean, not tomorrow, but Wednesday. We have to remember end behavior, limits, L'Hopital's rule. That's very recent. It's more like we have to know how the hell to use it, right? What else happened? This little business we just now did right here, with the fractional powers always freaks people out. Don't let it. So tomorrow is going to be devoted to nothing but review. So come with all your questions. And then Wednesday's the test. Oh.
mistakes you just see right off the bat.